My name is Dr. Esther Trufan, and in this video, I will be talking about significant figures. In chemistry, there are two ways in which we can determine values or numbers. There is the exact way that happens by counting, and that could be something like we replicated this experiment 3 times, or not exact numbers, and in that case, we have done some kind of measurement that included an estimate. So with the non-exact numbers, we always have to perform an experiment that uses an instrument. There is always a value and an uncertainty, and there will be a unit attached to that. For exact numbers, there's always a number, but that number has an unlimited number of significant figures. So if we say that we have 3 pennies, then that means we have 3.00000 until we get tired of writing it, pennies, for an experiment. Because 3 has been determined by counting, and it is an exact number. An example of a not exact number would be 25.3 grams. In this case, the value is 25. The 3 is the uncertainty that we determined by estimating, and the grams is the unit associated with the measurement. When it comes to determining what number and how many numbers are significant, there are some rules. Non-zero digits are always significant. So if we have 11, then that means we have a total of 2 significant figures. If we have 135, that gives us 3 non-zero digits or 3 significant figures. Captive zeros are zeros that are in between non-zero digits. So if we have 103, the captive zero is always significant. So in this case, we have 3 significant figures. Also, if we have 12.005, the 2 zeros are in between 2 non-zero digits, the 2 and the 5, giving us a total of 5 significant figures. When it comes to zeros at the end of non-zero digits, there are 2 rules. If we have a 0 after a decimal place, like in the case of 7.50 milliliters, then in this case, that 0 means that someone made the effort to estimate that number. It just happens to be 0. And that 0 is significant because it is after a decimal place. Another way in which the 0 can be significant, if we measure 5.00 grams on the scale is showing this number because we made the efforts to get as close as possible to the 5.00 gram mark. And in that case, both zeros are significant. So in the 5.00 gram amount, we have 3 significant figures. In the 7.50 milliliter measurement, we have also 3 significant figures. Many times we have numbers that are either very small or very large, and it makes the most sense to express them in scientific notation. For example, if we have 6.022 times 10 to the 23rd, all the significant figures that are before the multiplication sign are going to be significant. So here we have 4 significant figures. But if we only had 6.00 times 10 to the 23rd, then the 6.00 would all be significant, and there would be 3 significant figures there. The numbers that are not significant are leading zeros. And here, think about numbers that are less than 1. So 0.52. The leading zeros are not significant, and we have a total of 2 significant figures. Or we can look at an even smaller number. In this case, all the zeros before the first non-zero digit are not significant, but everything else, because it is after a decimal place, is going to be significant. So here we have 4 significant figures. For trailing zeros, if there is no decimal place, the number may or may not be significant. Let me give you an example. If we have 5,300. We should not make any judgment on how many significant figures there are. For sure, at least 2, but it could be 3 or it could be 4. So in all the instances where there could be doubt to the number of significant figures, it is best to convert the value into scientific notation. So if we have 5,300, let's say, grams, then it is best to convert it into scientific notation. If in scientific notation it will be 5.3 times 10 to the third grams, then we have 2 significant figures. However, if in scientific notation it becomes 5.30 times 10 to the third grams, then we have 3 significant figures. And if our scientific notation says 5.300 times 10 to the third grams, then we will have a total of 4 significant figures. And with these rules, we should be well equipped to determine how many significant figures there are in any number that is determined by either counting or measurement in the chemistry lab. And if we have those numbers, then we can do calculations with them. When we have addition or subtractions, then what matters the most is how many digits there are after the decimal point. And here is one example. In this case, we have 2 measurements, and these could both be grams or they could both be volumes. And I will consider them in milliliters. To add these up, we're going to simply add everything up. 4, 5, 17. The weak link here is the least sensitive measurement, and that is the first one. The first one only has 1 digit after the decimal place, which means someone was estimating that digit, but there is no estimate for the second digit after the decimal place. So we have to draw a line here, and everything that comes after is not going to be significant. So our final answer for the sum of these 2 values is going to be 17.5 milliliters. Because the number after the last significant digit, or the 5, was a 4, this one, that means we round down and it becomes 17.5. If it was higher than 5, then it would round up and we would say 17.6 milliliters. For subtractions, it goes very similarly. Let's say in this case, we also are working with milliliters. And originally we measured at 32.7 milliliters in a 50 milliliter graduated cylinder. We recorded the volume correctly. And from there we extracted 450 microliters or 0.450 milliliters with a micropipette. In this case, we also performed the calculation. And just like before, we're going to draw the line at the least sensitive measurement. Here, after the last digit that is significant, we have a 5, and that means the last digit is going to round up. So instead of saying that the answer is 32.2 milliliters, it will be 32.3 milliliters because the 5 rounds up the 2 to 3. For multiplication and division, what matters the most is how many significant figures our values have. Here we have 2 numbers and they get multiplied. The first number has 3 significant figures and the second number has 2 significant figures. This means that our final answer should have 2 significant figures. If we calculate this in our calculator, it will show 26.84. And then we're going to multiply the centimeter by the centimeter, giving us square centimeters. And then we remember that we had 3 and 2 significant figures, and there should be only 2. But because the third value is 8, it will round the 6 to a 7. So the correct answer will be 27 square centimeters. For division, it goes very similarly. We will need to calculate our number, and we will get 1.347556. And we can keep going because our calculator will give us plenty of numbers. And for the units, it will be grams and milliliters. These don't cancel, so we have to keep them both. Grams per milliliters will be our new unit. Now let's look at how many numbers are significant. In the first value, we have 5 significant figures. In the second value, we have 3 significant figures. So that means our final answer cannot have more than 3 significant figures. So that will be our 3. And the number after the third one is a 7, which means it will round the 4 to a 5, giving us a correct answer of 1.35 grams per milliliter.